We'll go ahead and get started. So this is Entity Framework Core Unchained, getting the best performance from your ORM. The spoiler is not don't use Entity Framework Core. So just want to get that out of the way. So we're going to start out, we're going to talk about configuration. Arguably, one of the more important pieces is making sure you've got your configuration right. Talk a little bit about access patterns. Entity Framework does some very interesting things with some CRUD operations. We'll learn about the really easy foot guns to find, and there are a couple. We are, of course, going to touch on database design because if you have a poor database design, nothing else that I'm talking about is going to matter. And then lastly, we're just going to have some honest conversation about things you shouldn't do with EF Core. Got a couple of war stories there, including a recent one where I did not follow my own advice. Always good. Right, who am I? So my name is Dan Mallott. I'm a senior principal for West Monroe in our product engineering practice. West Monroe is a business and technology consulting firm based primarily in the United States. We recently opened an office here in London. They're primarily focused with mergers and acquisitions, i.e. making money off of other people's work. There are less charitable ways I can describe it. I've been developing software since 2011 in various capacities. My first job, I was the DBA, not necessarily voluntarily, but now I primarily do development work, although a lot of times that means developing PowerPoints. Primary experience in Microsoft, I've also unfortunately written that 4-letter language. And I am a USA hockey referee. I put ice in parentheses because hockey here means something different than it does in the United States. Right, Twitter, GitHub, LinkedIn, if you want to get a hold of me. Right, so I'm going to assume you guys all know this, but I'm going to go over it anyway. So Entity Framework Core is made up of two components. There's an object relational mapper, which is taking the results of queries and mapping them into .NET objects, whether those be records or POCOs or what have you, right? And then the other piece of it is a really powerful query generator that translates your LINQ or LINQ statements into SQL that's actually executed on the database. Or whatever query language happens to be, right? If you're using Cosmos, that might be different. And the query generator is both the solution and the source of many of our issues. And I'll talk about that as we go on. But suffice to say that writing a query generator that is going to generate something that executes against every version of SQL going back to like, I think it's 2005, is a difficult challenge. Right. So let's talk about configuration, right? So when you go to add Entity Framework to your application and you go consult the Microsoft Docs, you get something that looks an awful lot like this, which is great. It's easy. It's a one-liner. Who doesn't like a one-liner of code, right? That's why we see nested ternaries everywhere. And so it's really just, we add the DB context, it's registered in our dependency injection container. I'm using .NET APIs, not in the minimal mode here, clearly. Connection string, in this case, stored in a configuration object. And we're good to go, right? It works. And it does just work. There are some things that are probably happening under the hood, or that are happening under the hood that you may not actually want. So for one, there's no query retry. Who develops applications that live in the cloud? Who develop applications that live on premise? Who develops an environment that has 100% uptime on your SQL server? Oh good, no one's lying to themselves. Right? Connections go down. Who develops in an environment where there's a DNS problem once a month? Well, nobody's admitting to that one either. Come on, it's always DNS. Right, so query retry is important, right? And for a long time, this was something that was sort of left to the developer to kind of handle. And in our defaults, we don't have any retry. That might be important. You might want that. All queries are tracked. What do I mean by that? So internal to the DB context, right? So the DB context is our container that holds all of our connection information and models and all the mapping information from the database. It will track all of the results that it brings back. And it does this for a couple of reasons. One, it does this because in theory, if you ask for the same object 4 times, Entity Framework Core is, again, in theory, smart enough to only ask the database for it once, right? Because nothing's changed. The other reason it does it is because Entity Framework Core has a huge amount of change tracking logic built into it, so that if I pull an object back from my database, make a bunch of changes to it, and call save changes, it knows exactly what to do to persist that to the database. Or if I pull an object back, I don't do anything with it, and call save changes, it does, well, you didn't do anything, so I'm not going to do anything. And this is really powerful, right? It automates a lot of that change tracking away from us, but that might not be the best thing for your use case. Related entities are explicitly loaded. Probably fine. What does that mean? It means that if I have a user that's a child to a post, it's going to load that. And you don't really get much logging of errors or warnings. You get a connection failed. So sorry, try again later. Again, in a production environment, it's fine. In your development environment, we might want some more information about why our exquisitely constructed LINQ statement that's 40 lines long failed. Right, so what can we do about this? Well, so first of all, there's a couple of things. This isn't all bad, right? I've kind of talked about that. Like, there are some things that are fine and some things that are probably not fine, right? So you do want to implement a retry policy. You do want to use the proper tracking behavior for your use case. I will dive into that much more in a few minutes. You do want to log errors and warnings in the development environment. You may also want to log some sensitive data if you were trying to make your debugging easier. And you don't want to enable lazy or eager loading proxies. Now, Microsoft is so on board with that one that those are no longer options unless you download specific NuGet packages, right? Lazy loading is where we get the n+1 problem, where, well, I got my users, I iterate through all their posts, and now I'm like querying the database like mad. And if you're in an on-premise environment, the SAN administrator's calling you. If you're in a cloud environment, your finance department's calling you. And eager loading is, I've just loaded the entire database by loading one user. Oops. Right, so here's a suggested configuration. Again, this is got an is development flag. Make that a little bit bigger. Right, so the first thing up there, got a retry policy. In this case, 4 times, 1 second each time. Now, you're going to want, just like you hear this a lot at conferences. This is example code. Don't do this in production. You're going to want to do something more clever, right? So in a cloud scenario, you probably want some sort of like Fibonacci backoff, right? Okay, 1 second, 1 second, 2, right? Okay, we all know that. But here it works fine, right? And you'll notice that error numbers to add. So the retry comes out of the box with a whole bunch of like, the database didn't respond, you had a login error. There's a couple other ones. But like it covers like your standard like 6 things that a SQL server might like barf up if it just happens to not be there. But you can add some, right? So like if you get a, for example, if you get a key conflict, right? Or if you get a deadlock or something like that, you can add those. In this case, I am putting in query tracking behavior no tracking. That's more just to illustrate how you do that. Again, we'll get to that in a minute. And then in development, we want to log some additional things. And I do very strongly urge you to do this, at least in your local development. If you're shipping your logs anywhere, consult your security people first. So the first is enable detailed errors. So that gives us field level errors. So if, for example, I try to stuff a 6, so in the United States, all of our postcodes are 5 digits, right? And if I am taking a US-centric approach to my database design and I've done a car5 or something like that, or varchar5, and I try to stuff, say, a UK postcode into it, it's going to tell me, hey, you're an idiot. Or at least you didn't think this through. Sensitive data logging, so that is, we're going to get parameter values. Really useful, right? Like now I know that my ID of 1 returned nothing, or my ID of 1 returned, like, caused an error, and I can go look into that in the database. Don't do that in production. Don't do that in production. Don't do that in production. And then I can configure some additional warnings. So these warnings give us additional information that Entity Framework Core is emitting, but usually not doing anything with. And in this case, the two that I always care about are a first without order by and filter warning. And so that's if I do a .first or default and don't order by or filter at all, right? The reason for that is most databases, order is not guaranteed in your query results. We all know that, right? Or we've all had to find that out the hard way. And the other one is a row limiting operation without order by warning, right? And that's for the same reason, right? Order is not guaranteed, so if I just call, give me the first 100 of these, give me the next 100 of these, I might get the same 100. Or I might, worse, get like 100 and then 50 new ones. Right, so these are useful things to get an error like, oops, I forgot to do this. Or, maybe there's a use case here that I wasn't covered in my user story, but I need to cover later on. And there are a huge number of additional core event IDs that get emitted by Entity Framework Core. Some of them are kind of like, ooh, I executed a query, thanks. Some of them are marginally more useful, but you can go on the docs.microsoft.com in the Entity Framework Core section and find out all of the ones that there are. There may be some additional that you want to use. Some of the ones that used to be optional are now guaranteed, which is kind of nice. There are also relational event IDs, which tell you some additional information about how Entity Framework Core is like dealing with your model against the database. Right. So let's talk about CRUD. By the way, I'm really easy to spot at conferences these days. I don't think I own anything that doesn't say West Monroe on it. That's what working at a place for a bunch of years does. Right. So the first thing that happens, so CRUD is create, read, update, delete, right? Okay, we all know that. So we'll take those in order. And the first thing we'll talk about is inserting records. Okay. If we insert one record, we get one insert statement. That's expected. But if we insert more than one record, we get a merge statement. And this is against SQL Server. Other providers will do different things. And so that's sort of interesting, right? Like, why is Entity Framework Core making that choice? And so those two lines, right? I just added a couple of users, called save changes, and got a merge statement. And you can see that I'm emitting all of the parameters. Okay. So you can see the data that I'm shoving in there, and then the SQL query. So this is a really curious choice, and it's a change in behavior. Who used Entity Framework 6 or previous? Okay, we've got a few, right? So this is different than what traditional Entity Framework did, right? and it's not entirely illogical. And for those of you who know who Brent Ozar is, he actually has a blog post from a couple of years ago that digs into this much more. But essentially, so single insert statements are slow. That's true-ish. Inserting multiple records is more efficient. Again, that's true-ish, right? As with everything, it depends. So the result of that thinking is let's use a merge statement to protect ourselves from strange SQL generation issues, right? Because if I were to go handwrite what it generated, I would use some sort of table-valued constructor in my insert, right? So that's insert my list of queries, and then select and hard code all that stuff in there, right? And so they chose to use a merge instead, right? Because building a table-valued constructor is weird, even though they actually are kind of doing that. So this isn't a bad choice, right? This is between using merge and using a bunch of insert statements, this is fine, right? In SQL Server, merge does have some issues with deadlocks. This statement is not constructed in a way that you're going to run into that particular issue because we are just inserting to the table. The deadlock issue happens when you're inserting or updating or deleting. But in your environment, it may make sense to force single insert statements, and we can do this. So the breakpoint is 3 or more records. So if you have 1 record or 2 record, you get insert statements. If you have 3 records, you get merge. It's an odd breakpoint, but I suppose they did some testing. But you can change the max batch size in your configuration and say, my batches are 1. This is fine. It does what you expect it to do. Now we'll get, instead of 1 merge statement, we'll get 3 insert statements. We'll get into something that's not so good side effect of this a little bit later on. Right. OK, reading data. I promised we were going to talk about query tracking. So reading data, we're just pulling data back from the database, right? Simplest thing you can do with an ORM. It's arguably the use case that you should be using an ORM for. And there's a difference, right? So if you're going to simply return the data like through an API or to like a UI on your screen, if you're in WinForms land, and you're not making any modifications to the entities that you pulled back, there is no reason to track them. 0. But if you're going to be modifying the original entities and saving them back, then you should use as tracking. Now, most of us, when we're building APIs, we have discrete read and update or delete or create endpoints. You're very rarely like pulling stuff and doing a whole bunch of and putting it back in, right, in a simple case. So you can mix and match these, right? So you can configure your default behavior and then on your query itself say, I do want this to be tracking, or I don't want this to be tracking, right? And so it's choosing which one is your majority use case. So in an API situation where you're serving a bunch of data, it's going to be no tracking. And then, OK, well, we're actually creating, so we need to track this guy. Updates and deletes, it's kind of is what it is, right? However, interestingly enough, updates do not generate a merge statement. They're just updates. Go figure. They always happen as single statements. So if I delete 1,000 things, I get 1,000 deletes. If I update 1,000 things, I get 1,000 updates. The only difference is if we mess with our max batch size, we get either 1 connection or 1,000 connections. Seems bad. So again, you want to pay attention to that. Speaking of easy ways to shoot yourself in the foot. Okay, so bulk manipulation of data, bad. Don't do that with Entity Framework. Lazy loading entities, bad. Don't do that with any ORM. Using tracking for read-only scenarios, not bad, but you're costing yourself about 30% of your performance. May matter. And then retry policy. Things fall offline for a minute. So interestingly, I harp on the retry policy because when I was putting together the code samples for this talk, I was using a SQL Azure serverless, which is great because it's really cheap. It's not great because it goes to sleep every like 10 minutes of non-use. And then the first query that you run after it starts up times out while it's waking up. Fun. And then your app throws a big giant exception because it couldn't even create a connection to the database because it wasn't awake. Great. Okay, so what are some other ways to destroy performance? How many people run scaffold DB context and just go with it? Great. Don't do that. But using the auto-generated entities in general can result in far too much data coming back. Loading too many related tables or too few. So loading related tables .include, that adds joins to your statement. It adds complexity to your statement. If you do like 6 of those, fine. If you do 60 of those, write yourself a view. Async. The async programming model is really, really mature in .NET at this point. You should use it. The async for each one, that's a weird construct, but it works. And then defeating indexes by not understanding how your database uses them. Got an example for that guy. Right, so what are the solutions here, right? So we can project only what we need out of a query, and Entity Framework Core is smart enough to only pull back what we need. Yeah, that's gonna result in better performance. Only include the data you actually need, right? So if I'm loading up a user profile and I just have this like generic get user, so all my examples are from Stack Overflow, so like users have posts, right? And I always load the posts, like I probably don't need to if I'm just showing a user's profile. Always use async, unless you have a really good reason not to. And then learn a bit about how your database engine chooses which indexes to use. Like I said, we'll get into that. All right, so how can we use select to limit fields? So everybody in here has used Stack Overflow, right? Yeah, okay. So in the Stack Overflow database, the posts table includes a whole lot of stuff. But say I'm just gonna show the body of the post. Well, I really only need the body and probably an ID so that I can keep track of it. There's no reason to load the entire post entity. So what I can do is define myself a custom post entity in a different namespace. Project our query, right? So that's what we talk about with the select guy. That's a projection. And then we get one, much smaller SQL, which shows better in our log. But 2, we get less data coming back, right? And so the less data you send over the wire, the faster it's going to go, right? We can't defeat physics yet. Just as an interesting thing, you guys probably noticed I used singular default, and I got top 2, which Entity Framework does to tell you if it gets more than one result, so it can throw an exception at you. It's nice. Cool. Async. Yeah, not a lot to say that I haven't already said. Essentially, the top one is going to perform better than the bottom one, all else being equal. Now, if you have 10 users, who cares? If you have 10 million users, you're probably going to want to do this. Also, if you have constraints about like auto scaling in the cloud, things like that. Under load, async is going to give you more responsiveness. That's it. Indexing, right. I did mention I was going to talk about this. So indexes are great, right? How many of you have a DBA group that you get to work with? A couple. Okay. How many of you also play the role of the DBA? We've got a couple there too. Yeah. So I have a slow query. You could put an index on it that's going to speed it up, right? Grumble, 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 sure. I will say indexes will also slow inserts, updates, and deletes because you have to update the index. But the really important thing here is that indexes are only used in certain circumstances, and this depends on your database engine. So here we're talking SQL Server specifically. If you have an index on a string field, whether that be ANSI or whether that be ASCII or Unicode, and you use a wildcard in your search, and you start the search with a wildcard, SQL Server will not use your index. So if you say ends with instead of starts with, you are now no longer using your index, and your query is going to be slow. Now, depending on the size of your table, it may not matter. Depending on your SLA for returning the data, it may not matter. But when it does matter, it matters. Right? So try to only use the starts with guy. And there are ways to get around that. So like, you know, if this is a really common use case, you can create a computed column and reverse your column so that now you're just reversing what you're searching on. And then indexes are generally not used when you're doing an operation on the column. So for example, answer count divided by 2. But yeah, reach out to your DBA team, should you have one. Or, you know, put your DBA hat on if you're the DBA too. Because they want to help. They really do. Hey, how can I speed up my slow query? Like, well, can you rewrite your query? No. They want to help. They really do. How are we doing on time? Okay. Database design. How many of you get to work on a product where you're designing your database from scratch? Oh. Great. How many of you have a database design that's like 20 years old? Yeah. Generally. Clients. Right? Because you only get one chance. And once there's data in there, changing a database is really, really hard. It's a hard problem, not to mention all of the governance around it. Right. So some general guidance, right? Do it right the first time. For most of us, that ship sailed. But you know, think about the proper design patterns, and specifically design for your access patterns, right? So, you know, 20 years ago, when all we had were relational databases, it was like, yes, you should go full like third normal form or whatever normal form, right? Because that's a pure design. And then along came these things called NoSQL databases for not only SQL. You're not writing SQL. And all of a sudden we started to think about like, well, maybe it's okay to have some data duplication if that speeds up our results, right? Like, if any of you are using Cassandra, right, that's like the entire design philosophy is you can have like 60 copies of your data and it doesn't matter because you get it fast. And then, you know, you have to like worry about keeping it updated, but. Right, but so discard pure relational patterns when it makes sense, right? So in a pure, as an example, in a pure third normal form pattern, right, you would have a country table that you look up against, and then you would have a country ID on your address. That is silly. You might have a country table because you might need to display those countries in a UI. But having a foreign key to your address table is just adding overhead that you don't actually need because you're gonna have to do that join every time, right? So why not just chuck that text onto the address object. Right. Poor design equals poor performance. So one of the first things I did in my career was migrating a bunch of FoxPro data, I haven't lost my hair for nothing, into SQL Server. And for those of you who know anything about FoxPro, like it's fixed width and files and oof. And the first attempt was, well, we'll just replicate that pattern in SQL Server. And that worked terribly, so then we had to go and like redo it, right? So poor design, poor performance. Avoid table per type. This is one that is kind of more challenging in some cases, because Entity Framework makes it really, really easy to do one type, one entity, one POCO, one whatever, to each table. 90% it's fine, but there are cases where maybe you've split tables or you have like, you know, something that's better represented as an enum, like in my country example, that like really like the shape in the database is not how you should be looking at it as an object. Or likewise, the shape as an object is really not how you should be looking at it in the database, right? So don't marry yourself to table per type. Use your database as tools, right? So these are things like views, computed columns, stored procedures, shutter. But doing these things can help reduce the amount of work you're making Entity Framework and your database engine do. And then lastly, and perhaps most controversially on this slide, avoid code-first tools. I will preface that by saying code-first for a quick start or something where you're just trying to get off the ground, or again, servicing like 10 users, totally fine. It doesn't scale well. So we have an internal project that we use to help utilities in the United States manage people's applications for putting solar panels on their roof. Because there's a lot of stuff that goes into that. It's 7 years old. It started out life as a .NET MVC monolith with AngularJS on the front of it, and they used code first. And it was fine because this was a really small use case with like, 2 applications a day that our local utility was using. 7 years later, now we're trying to, strangle the monolith, break it into services. We've added functionality in microservices, and all of a sudden, code first is a giant pain because it's in one project in our monolith. They've had to rebaseline I think 15 times to get any sort of decent performance. So again, if you're starting with it and you need to start fast, or you're doing something small, it's fine. Long term, All right, so what do some of these things look like? So as far as Entity Framework Core is concerned, a view is just the same as a table. You just need to tell it it's a view so that it doesn't try to generate, so that it stops you from inserting things. So Stack Overflow again, posts have a post type. Now, are you ever going to pull back a post without its post type? Probably not. There are a couple of different ways to solve it. In this case, I chose, let's just add the type and the join and wrap it in a view, so that we aren't having Entity Framework do that work every time. Because, and I don't have an example of the generated SQL, because then it will just select the view columns, right, from our post with post type view. And this it's cleaner, right? And you can control what the SQL looks like, right? Right, code first, kind of talked about this a little bit, but some other specific pitfalls. Data types, There's some really unfortunate defaults. There's no reason to store every string field as a Unicode. Now, if you're building a big international app, many of them probably have to be, but not all of them. You are left to define your indexes. You probably get an index on your primary key, particularly if you're using SQL Server. But now we're adding indexes when we're running our migration. That's going to be slow, which if you're running your migration as part of a CI/CD process, the last thing you want is your CI/CD process to be slow, because then people won't merge and build as often. And right, you have to write views manually, so you are going to end up writing SQL there. For me, not so scary. For other people, maybe more scary or more annoying. And then code first generally doesn't utilize more advanced database features. Again, it's a size of data problem, right? Most of the time, you're not going to table partition. Most of the time, you're not using in-memory tables or things like that. You might want some user-defined types. When I get to I shot myself in the foot story, I'll tell you about that. Right. So let's talk about the things that Entity Framework Core is really bad at. Lots of joins. I had a great example of this from Entity Framework 6 that was like this wonderful arrow pattern of a query, and I've lost the image, unfortunately. But if you have a lot of joins, so include, EF Core is going to struggle to produce good SQL. It's not only it looks ugly, but it is actually not optimal. ETL, yeah. So how many of you are aware that Rebrickable publishes a data set of all of the Lego sets and pieces and minifigures? Yeah, got one. So rebrickable.com, you can go and download the data set. And I got tired of using Stack Overflow, so I said, oh, I'll use this Lego data set. This is great. I like Legos. Everybody likes Legos. They have a nice ERD. You can do it. It's really nice. And they publish it in individual CSV files, so it's kind of on the user to figure out how to get that into a data structure, right? So download the CSVs. I go, oh, well, this is something small and quick. I'll just use Entity Framework Core for loading it, right? Not kind of ignoring that at least one of the tables is over 1 million rows. So I go and I write all the code and I do some like genericization so that I don't have to like write these, write the same code 15 times. I go run. And I run it just on a small table first, just on like a 10-row table. Like, okay, it works, cool. Let me run it on everything. Got to that 1 million. Some of them were kind of slow. Got to that 1 million row CSV, over 1 million row CSV. And I went, oh, I guess I'll go get a coffee. So I went to get a coffee, came back. Nope, still not done. Ran my little test query like, oh, it's inserted like 3,000 records. It's not good. Went and talked to my wife, who's in the next room. Working from home is wonderful. Came back, hit the query. 15,000. Well, I'll go like clean the cat box. Went and cleaned the cat box. Came back upstairs. My computer had gone to sleep, and the application stopped because I was loading everything locally in a Docker container. See, I didn't follow my own advice. So, yeah, don't do ETL in the Framework Core. It's going to be very slow and it's going to be very painful. I rewrote it to use a table value parameter, which you create a table type in SQL Server, you shove all the data into a data table in .NET, and call a stored procedure, and it's an insert, and it runs very quickly, and now it runs in less than 2 seconds to load that 1 million row table. Right. Don't be me. Follow my advice. And lastly, parameter issues. You will know this if you run into it. And that is, a parameter issue can be as simple as you're feeding a Unicode string in where it's an ASCII string, or you're feeding an ASCII string in where it's a Unicode string, and SQL Server says, well, these things are close enough, I'm not going to complain about it, but I'm also not going to use an index. Thanks. And there's just some times when it's going to do the wrong thing, and you're going to have to write SQL to fix it, unfortunately. Okay. So the primary goal, and this is really important to remember, Entity Framework Core's primary goal is reliable execution. Right now, the team has done a ton of work to improve performance. Like if you haven't used it in a while, or if you're using an older version, it is worth updating to 6. Actually, it was worth updating to 5. It's really worth updating to 6. But its goal is to be reliable, right? So the SQL it generates is not going to be the most performant. This really matters when you're going against Cosmos DB, because how do we pay for Cosmos DB? Yes, by query time. Great. The other thing is that the pre-compilation items, so you can now compile your queries again with EF Core 6. Don't have a demo for that, unfortunately. But that can also provide some better performance and also more repeatable performance. But the thing is, there is significant overhead associated with all of this, right? It is a full-featured ORM with all of the good and bad things that comes with. And, that just creates overhead, which is fine, right? If you really, really need performance, raw ADO or something like Dapper, right? Like if performance matters that much, use something that is closer to essentially writing it yourself. It's going to take more work, so there is an ROI there, right? But yeah, that's it. Right. So I've gone very fast. I hope you guys have questions. Right, so understand how it works, how it doesn't work. The docs are your friends. They're really much more useful than they used to be. You want to measure performance, and if you've done 1 and 2, you're going to have 3, which is have a plan to fix it when it goes bump, right? That happens to everybody. This thing that worked all of a sudden doesn't work, right? All right. Questions? I went very fast. No questions. I was perfect. I'm going to see nothing but greens in the bin out there. And then all the reds in the little Tupperware thing, right? Yeah, so that's really all I have. If you have questions that you don't want to ask in front of the entire room, feel free to come up and ask me. As you are leaving, please make sure you fill out an evaluation. That's very helpful for me. It's very helpful for the organizers. And thank you all very much.